So, today we're talking about applications of trig functions. We're still using the same sine, cosine, and tangent. We're still going to separate them. No. We're still going to highlight. We're still going to set them up. We're still going to do everything exactly the same. Okay. The only difference is that we have to draw the triangles today. Okay. Based on our word problems. So, some of the problems have angle of elevation and angle of depression. So that's what our first little diagram here is. So when you're drawing these triangles, you always want to draw them from the eye level of whatever that you're talking about. So like if we're talking about this dog, then the eye level of the dog, if he's just looking straight, is just straight ahead. But then, as he looks up at this bird, this is the angle that his eyes are moving. So this is your angle of elevation. Okay? So you draw regular old eye level, and then if he's looking up at this bird, this is the angle that's changing. Okay? So the one that's kind of different is angle of depression. So angle of depression is when you're up on something and you're looking down at something. So if we're talking about this bird, again, if he's just looking straight, this is his eye level. But then if he's looking down at the dog, this is the angle of depression. Okay? So some people get confused on that. But you're always drawing from the eye level, and then if they're looking up or if they're looking down. Okay? So let's do number one. So number one says, suppose the angle of elevation to a hot air balloon is 38 degrees. The horizontal distance between Jim and the balloon is 50 feet. Jim is 6 feet tall. How high off the ground is the balloon? Okay, so we're talking about Jim over here. Okay, and we're talking about a hot air balloon. We're just going to draw a regular balloon because I can't draw a hot air balloon. Okay. So we have Jim and we have a balloon. Any questions on Jim and the balloon? Okay. So to draw our triangle, we draw Jim's eye level, which is right here. Okay. And it tells me he's looking up at this balloon at an angle of elevation of 38 degrees. So he's looking up at this balloon. His angle of elevation is 38 degrees. Question on that? Okay. So then we just finish out our triangle. And so over here is our right angle. So then we look at what other information it gives me. So it says the horizontal distance between Jim and the balloon is 50 feet. What is horizontal distance? Left or right. Good. So think the horizon, horizontal. So from Jim to where the balloon would be is 50 feet. Okay. What I'm trying to find is how high off the ground is the balloon? So am I trying to find the hypotenuse or am I trying to find the opposite? Opposite, good. So we want to know how far from the ground to the balloon is it? Questions? Okay. Well now, it's just a regular old, if you take away Jim and the balloon, it's just the triangles that we've been doing. So 38 is our special angle. So if we highlight, we've got here and we've got here. If you need a highlighter, you can come and grab one. And so then here's our right angle. So here's our hypotenuse. 50 would be our adjacent. And then X is what we're finding. It's across from 38. So that's our opposite. So which trig function do we need to use? Tan. Good. So tan of our angle, which is 38, equals, opposite is x, our adjacent is 50, So then again, we just solve it for x. It's x divided by 50. So to get rid of divide, good. So we times by 50 on both sides. Make sure you're in degree mode is always your first step. So then 50, 10 of 38. And so hopefully you get 39.06. feet. So is that how high the balloon is off the ground? No, why? Yeah, because Jim is 6 feet tall. So we drew his eye level, so then we need to add in this little tiny piece here, which is 6 feet, so add 6. Good. Now, it won't always tell you that height. If it doesn't, that's okay. You don't have to worry about it. But if it tells you, like, so-and-so is 6 feet tall, or such is however many feet off the ground, then you do want to add that in at the end. Any questions on that? Okay. Let's look at number 2. So number 2 says a person standing 30 feet from a flagpole can see the top of the pole at a 35-degree angle of elevation. The person's eye level is 5 feet from the ground. Find the height of the flagpole. So again, in this one, we have a person. And we have a flagpole. So it tells me the person is standing 30 feet away and they can see the top of the pole at 35 degrees. So our first line is always, if they're just looking straight, what is their eye level? So this person is just looking straight, so that is their eye level. But they're looking up at the top of it at an angle of 35 degrees. So their eyes are looking up at an angle of 35 degrees. Questions on that? Okay. So then it tells me that they're standing 30 feet away. So if they're here, the flagpole is 30 feet away. So again, that's that bottom distance. And we're trying to find the height of the flagpole. So this is my flagpole. I'm trying to find x. Questions? Let's draw it. Alright, so when we label it, here's our right angle. So we highlight our 35. That gives us our hypotenuse. That gives us a 30 is our adjacent. And then across we have opposite. So which trig function do we use? Good. Tan again. So tan of 35 equals, and then opposite over adjacent, so x over 30. And then how do I solve it? Yeah, so we times by 30. So then we do 30 times 10 of 35, and so we get about 21.01. So then what would be my final answer? Good, 26, because it tells us the person's eye level is 5 feet from the ground. So we have to add in this little tiny 5 down there. So 26.01 feet tall. Again, if it doesn't tell you their height, you can ignore it. But if it does, you do want to add it in at the end. Any questions? Okay. Alright, let's skip number 3 because it's the exact same thing. Let's look at 4. So 4 says we have a pilot traveling at a height of 30,000 feet above level ground. She looks down at an angle of depression of 6 degrees and spots the runway. As measured along the ground, how many miles away is she from the runway? So this one is different because we have a pilot who's looking down. So we're looking at angle of depression. So if we draw this one, we have a pilot. She's up here in her airplane. Okay. And she's looking down and she sees the runway. Okay. So our first line is always her eye level. So if she's just looking straight out into the sky, this is her eye level. Okay, so she's just looking straight out. But it tells me she's looking straight out, but then she looks down to see the runway. So she looks down to the runway. And it tells me that angle is 6 degrees. Bless you. Any questions on drawing that? Okay. So then if we finish out our triangle, here we are. Any questions on that? Alright. So it tells me that she's traveling at a height of 30,000 feet above the ground. So if this is the ground, she's above the ground 30,000 feet. So that is our vertical distance here. Okay. Because that's how high she is off the ground. And so we're trying to find out, measured along the ground, how many miles away is she from the runway. So from the plane to the runway along the ground is our horizontal distance. So that's this same side as that. Yeah. Yes, because we want to know how many miles. We'll do that at the end. Okay, so now we can highlight it and solve it out. So here's our 6 degrees. So across from our right angle, we have hypotenuse. X is our adjacent. And we're going across the triangle, so that 30,000 is our opposite. So again, which trig function do we want to use? Tan. Good. A lot of these are tan. So we do tan of 6. And then it's O over A. So 30,000 over X. So for 1 and 2, our X was on the top, so we just multiplied and we were done. This one's a little bit different because X is on the bottom, but remember our first step is still to multiply. So we multiply both sides by X. So we get X tan of 6 equals 30,000. And then how do I get X by itself? Good. Good. So we divide by tan of 6. Just like this. And so we get that big huge number. So 28,543.93. But this is in feet. So my question says, how many miles away is she from the runway? So I want to take this feet and turn it into miles. How many feet are in 1 mile? Good. So 1 mile equals 5,280 feet. Good. So to convert, what we need to do is divide by that 5,280 feet. And so we get about 54.1 miles. Good. Any questions? Bless you. Oh, let's do one more. So our last one says a dog who's 8 meters from the base of a tree spots a squirrel in the tree at an angle of elevation of 40 degrees. What is the direct line distance between the dog and the squirrel? So we have a dog down here. Don't make fun of my dog drawing. It's pretty good. So we have this dog, and he sees a squirrel in a tree. Terrible squirrel, but it's fine. So again, our first line is the eye level of this dog. So he's looking at this tree. like that. But he's looking up at the squirrel at an angle of elevation of 40 degrees. So he's looking up at this squirrel at 40 degrees. Okay. But it tells me that he's 8 meters from the base of the tree. So from the base of the tree to the dog is 8 meters. So this one's a little bit different because we want to know what is the direct line distance from the dog to the squirrel. So we don't care how high up the tree this squirrel is. We just want to know directly from the dog to the squirrel, how far is that? So in this one, we're finding the hypotenuse. And so if we finish our triangle, here's our right angle. Now this one doesn't tell me how high the dog's eyes are, so you don't have to, well actually we don't even need that, so it doesn't matter. So cool. So we highlight 40 and our sides are there. So our x is our hypotenuse, 8 is our adjacent, and then we don't really need it, but over here is our opposite. So which trig function do I use? Good. So we do cosine of 40. And then it's a over h, so 8 over x. And then we multiply both sides by x. So that gets rid of that on the right. So we have x cosine of 40 equals 8. Bless you. And then what's my last step? Good, divide. And what do you get? Good. 10.44 meters. Very good. Any questions?